So this video is going to go over what is happening in the flame test. So what we see versus what's really happening to the electron. So that's what this video is going to go over. So find this diagram somewhere in your note packet and put notes on the top just so you have that for your reference. So this little diagram is kind of showing you what is taking place when you put something into the flame. So please understand that this dot here is an electron, and this electron is moving to a higher energy state. So in order to move the electron, we have to put what we call energy in. So please note that this is called the ground level or the ground state of the electron. So this is where the electron normally is. But when we do an experiment, we are putting energy in. So draw an arrow pointing in and put flame underneath it. So in the flame test, we put a compound into the flame and gave it energy. So the electron is starting at what we call the ground state. So that's where it normally exists. So let's say this is energy level 1. Let's say this is energy level 2, and let's say this is energy level 3. And again, the one thing I don't like about this diagram is these energy levels should not be equally spaced. That's what this experiment kind of proves. So I put enough energy to move the electron from this energy state up to this energy state. So we call this the excited state. And the excited state is where the electron is just for a period of time. Once it has gained that that energy, it goes to a higher energy state. Maybe it goes to energy level 2 instead of energy level 3, but it depends upon how much energy you're putting in. Well, of course, just like human beings, we can't exist in an excited state for too long. So the electron comes back to a lower energy state. Let's say it comes down to this energy state. When it does that, energy has to be released. So energy is coming back out, okay? And it comes back out in the form of a photon. And I will give you a definition of that. It's just a essentially a unit for light. And in our case, for the flame test, it is in the visible range. It is in the visible range. So again, you're going to hear the terms absorbing energy and emitting energy. Those are going to be terms that you're going to hear over and over again. So the electron comes back down to a lower energy state, but it could still go down one more state. So it could come down all the way to where it started from. And so it would have to release a certain amount of energy out again in the form of a photon, and you would see it maybe in the visible range. But realize that this is, again, just energy, light coming out. So it could also be in other parts of the electromagnetic spectrum, but we won't talk about that for now. Realize that if the electron started down here and went all the way up here, these electrons coming down first here and then down to here, these are called transitions. And all that means is essentially the electrons can move from one energy state to the other, depending upon if it's absorbing energy or releasing energy. And if I put a certain quantity of energy in, it has to release that amount out. So again, this diagram's not perfect, but if I put the energy in, that quantity of energy has to equal the two energies that are coming back out if I'm bringing the electron all the way back down to where it started, okay? So that is what we call transitions of electrons. We have to put energy in, it goes to an excited state, comes back down, goes to the ground state. And what you are seeing when you do the flame test is that light coming out. And this is how scientists figured out that these energy levels were not the same. If they were, the light that would be coming out would be the same color each time, but they're not, because they started to understand Planck's equation, which is energy is equal to Planck's constant times the frequency. So if you see red light versus purple light, you have a different energy. So that means these distances are different depending upon, again, where the electron is starting and where it ends up. But these energy levels never seem to be the same. So that is what scientists figured out by doing this experiment. So two definitions that I want you to write down. And again, if you have some space down here or maybe over here on the left, are two sets of words that you're going to hear being used. One is the big one, which is what we call the quanta of energy, quanta of energy. So quantum energy means the amount of energy needed to move electrons to the next energy level. So it needs to be a certain quantity. If I don't have that amount of energy, I can't get it to go to an excited state. So again, I guess if a visual would be, if the electron is starting here and I only added so much energy to get right here, it would not go to a higher energy state. So these levels are quantized. So there's an actual number, an actual amount of energy that you need to put in there in order to get it to a higher energy state. So if you don't have that quantity, it won't go to that state. So that's why it's called a quanta. So it's a quantifiable thing. We're not going to do the math with it, but you can do math with it. And then the photon, okay? It's a unit of light, essentially. So it's kind of like an atom is to matter, meaning atom is the smallest thing in matter, but we know protons, neutrons, electrons, and stuff like that. But it's kind of a way to think about it. So the photon is essentially the smallest thing of light. And again, it is radiation with no mass, and it has energy. So again, we could quantify that energy by doing energy is equal to Planck's constant times frequency to figure out exactly how much energy we're getting out. So with these two definitions and the diagram, okay, that is how we kind of explained the flame test, okay? And what you are seeing is the energy coming out, okay? You're not seeing the energy going in. Yes, you see the flame and everything, but it's really the energy that's coming out that we have some data that we could do something with in order to figure out the energy levels, So that's the background for the flame test. That's the background for the flame test.